have, and also to discuss about the future plans when it is about participation, not only in Visegrad funds, but also, for instance, Horizon, Europe and Erasmus Plus project. So I wish you very successful work, and I hope that we will have future possibilities to meet together. So thank you for the organizer, and I wish you successful work. Thank you.
Thank you, Professor Arsic, for your welcome speech and for your time devoted to this event. Next person or coordinator of this project, DigSTEM project, will give you a welcome and introduction speech. Professor Vladimir Maksimovic, please, Professor Maksimovic, take the floor.
Thank you, Alexandra. Good afternoon to everyone. My name is Vladimir Maksimovic from University of Mitrovica in Kosovska. Before we start, I would like to thank everyone who attend this meeting and thank everyone who participating in this project. I think this is a great opportunity to see how we use digital technologies, how we use our modern laboratories in our teaching process. But before that, we will present some results of the survey that we conducted in our institutions. And after that, we will present our laboratories, our using of digital technologies. And that's all. I'm sure you will enjoy and learn something new, see our capabilities of faculty, of university. So thank you once again and enjoy. Alexandra.
Thank you, Professor Maksimovic. Now we are ready to start with the main content of our agenda for today's webinar. So the first topic we will analyze and introduce today will be results on DigSTEM survey. So we will have a few presentations. First of them will be presentation by Dr. Jelena Todorovic from University of Mitrovica. So please, Jelena, take the floor.
Hello to everyone. Sorry for delay because of technical issues. Can someone tell me if you can see the shared screen?
Yes, we can see it.
Okay, thank you, Blerina. Okay. Hello, I'm Jelena Todorovic, and I will present the results of the survey that we conducted in our faculty. More detailed analysis of the result will be present in publication after the webinar, and a brief overview is provided here. At the Faculty of Technical Sciences, the survey was completed by students of all fields of studies, with the largest percentage from electrical and computer engineering. About 10% of the total number of students at the faculty filled out the survey. About 81% of them are in bachelor studies, while 50% are in master studies, and the rest are in PhD studies. The majority of students, more precisely 57%, are not familiar with the term STEM education. And they said they had a few to most subjects focused on a combination of math, problem solving, technology, and science. To the question, how many subjects have they taken in each of these categories, the students answered that they attended mostly about 30 to 40% of subjects in each of these categories: science, engineering, mathematics, computer science also. The largest number of the students answered that business and industry, unfortunately, is moderately involved or not at all in education, in STEM education at the faculty. Therefore, the majority of students do not implement projects with industry partners, or they do not know anything about it, they have no information about it. Somewhere between 70 to 80% of students have classes in computer classroom or specialized labs, which is pretty much a good percent of them. About a majority, the majority of the students said that there is about 40% of all subjects in which they use digital technology most of the time there. Okay, 41% of students plan to continue in STEM education rather seriously in the future, while about 25% of them plan to continue less seriously. Only 2% of students do not want to continue in STEM education. The majority of students see themselves in STEM career, what is really good news, and about 6% of them are already engaged in it. That's a survey for students, and about survey for teachers. Teachers from all departments of the Faculty of Technical Sciences participated in the survey. Most of them have 5 to 10 or 10 to 20 years of teaching experience at university. Most teachers say that their teaching is focused on STEM education, and that the STEM curriculum in their lecture is multidisciplinary, where science, technology, engineering, and mathematics are integrated. The next graphic shows the approaches that teachers use in STEM teaching. Teachers mostly use the project problem-based approach, where students are engaged in learning through the investigation of real-world challenges and problems. Also, teachers estimate that they are well able to follow the trends in the STEM, and the majority would be really happy to improve further in this area. Unfortunately, also, like students, most teachers feels that business and industry are underrepresented in STEM education at a university. They would strongly support in all initiative for collaboration between industry and university. On the next graphic, we can see the assessment of university industry cooperation in STEM education. For example, we can see that teachers think that, that visits to companies or training with students are rarely or occasionally possible. So we can really improve that part at our faculty. More than 55% of teachers say that STEM labs are available to them for teaching. Also, about 70% of them have technological support in the implementation of STEM education, and they believe that the availability of technological equipment does not limit the quality of STEM teaching. The following graphic provides an overview of the resources that teachers use most when implementing STEM education. And for the end, teachers estimate that students generally makes really good progress in combined STEM subjects, and that teaching is simpler and less demanding for students when STEM is used. So that was a short analysis of the survey that we conducted. The more details and information will be presented in our publication after the webinar. Thank you for your attention. If anyone has any question, or Alexandra.
Thank you, Dr. Todorovic, for your presentation. Does anyone have some question in relation with this presentation? If not, we can start with second presentation within this topic. Universum International College. If I am not in pronunciation, please, Diana Latifai will present
Yes.
the presentation. Okay, hello.
Thank you very much.
And please take.
Hello. I'm trying to share the screen. Can you please tell me if you can see the slide?
Yes.
Okay, thank you very much. I will continue with the professor's survey results. We had 4 professors from the field of computer science, economics. We had 3 professors and 1 professor from management and 1 professor from politics and math. Their position was assistant professors, where we had 4, lecturer, we had 3, and full professors, researchers, and external lecturers, we had 1 person. We had professors with their teaching experience in the span of 1 year to up to 10 years. And we had 9 male professors and 1 female professor. In the first question, has the science, engineering, maths, technology, education been integrated at your faculty? We had 5 people that answered yes, definitely, 3 rather not, and 2 rather yes. How much focus does your teaching have on STEM education? We had low present 3 people, low 3 people, sufficiently present 2 people, and moderately present 2 people. Do you provide lectures, courses with elements of STEM education? We had in the science field, 4 professors said 5 courses, 2 said 1 course, 2 others said no courses at all, 1 professor said 2 courses, and 1 said 4 courses. Engineering, we had 6 professors that said 5 courses, 2 no courses at all, 1 with 1 course, and 1 other professor said 4 courses. Mathematics, we had 4 professors with 5 courses, 5 professors, excuse me, with 5 courses, 1 with 4 courses, 1 with 3 courses, and 2 courses, 1 with 1 course as well, and 1 with no courses at all. Computer science, we had 6 professors with 5 courses, 1 professor said 4 courses, and 1 with 3 courses, 1 with 2 courses, and 1 with 1 course. And other digital technologies, we had 6 professors with 5 courses, 1 with 4 courses, 1 with 2 courses, 1 with again with 2 courses, and 1 with no course. In the STEM curriculum at the lectures courses that you are teaching multidisciplinary, and does it include lectures that are integrated? We had 4 professors that said yes, definitely, 3 professors rather yes, 1 professors, we had 3 professors that answered mostly yes, mostly no, and rather not. Which pedagogical approaches do you use in your STEM teaching? 9 professors said traditional teaching, where the teachers give information and students learn from it. 5 professors said teaching with experiments, 7 said project problem approaches, 5 said inquiry-based science education, We had 8 professors that said collaborative learning, 6 professors with formative assessment, and 1 professor said, I use some of the above mentioned elements with real-world problems. Please evaluate the STEM implementation in your teaching. I use STEM approach in teaching. We had different answers from always, often, more often, occasionally, and rarely. I frequently integrate science, technology, engineering, and mathematics within one curriculum. We had 5 professors said always, 3 often, 2 said rarely. My STEM approach motivates students for more active learning. 5 said always, 3 said often, 1 said occasionally, and 1 said rarely. STEM approach is for me crucial for preparing students for real challenges in their future careers. 4 professors said always, 3 often, 2 rarely, and 1 more often. I regularly adapt STEM education system based on the number of students and their knowledge. 3 said often, 2 always, 2 more often, 2 rarely, and 1 never. Preparing for education using STEM methodology is time consuming for me. 4 of professors said often, 2 always, 2 more often, 1 occasionally, and 1 rarely. I regularly educate myself and explore new possibilities in STEM education. 3 said always and often, 2 more often, and 1 occasionally and rarely. How would you rate your ability to follow and implement current trends in the STEM? 4 professors said excellent ability, 3 said poor ability, 2 said good ability, and 1 said very good ability. Could you consider additional training and professional development to better incorporate current STEM trends into your teaching? We had 30% that answered yes, 20 said yes, definitely, 30 maybe, and 20% yes, probably. Are businesses and industry also included in STEM education at your university related to your course subjects? We had 30% that said very involved, 20% said sufficiently involved, 30% moderately involved, 10% very low and low. Please rate university industry cooperation in STEM education in your teaching. So facilitating company visits, we had 3 professors that said always and occasionally. We had 2 professors that said frequently and rarely. Having STEM professionals at universities, we had 4 professors with frequently, 3 always, 2 occasionally, and 1 rarely. Student trainings, we had 3 that said frequently and always and occasionally, and only 1 rarely. Assigning tasks by business industry sectors, we had 3 that said frequently and always, as well as occasionally, and 1 rarely. Solving tasks for business industry sectors, 3 said always, occasionally, and 2 frequently and rarely. Financial support, 4 professors said frequently, 3 said occasionally, 2 said always, and 1 rarely. Do you have other types of university industry cooperation? 6 professors said no, while 4 professors said yes, some being involved in projects and some in dual studies. Would you support initiatives that facilitate cooperation between industry and universities? I would very much support 6 professors. I would support 3 professors and 1 professor said with much support. Do you think that current support for STEM education from university is sufficient? We have material that we have occasionally supporting, always supporting, and more supporting, in total 9 professors and 1 often supporting 1 professor. Financial, we had always 3 professors, more often supporting 3 again, and occasionally supporting 3 professors, and only 1 professor never supporting. Networking, occasionally supporting 4, always supporting 3 professors, more supporting 3 professors. How would you rate the current availability for literature and materials to support teaching STEM in your subjects? We had 40% of good availability, 30 excellent, 20 poor, and 10 very good. Do you think the current availability of literature limits the quality of your STEM teaching? 30% a little limiting, as well as does not limit much, but we had does not limit at all with 30% and limiting with 10%. At the STEM laboratories at your faculty, are the STEM laboratories at your faculty available for your teaching purposes? We had 40 with very available and available, and 10 with very low available and sufficiently available. Do you have sufficient technological support when implementing STEM education to your subjects? We had 30% with very present and not at all, and sufficiently present, 10% with low and very low. Do you think the current availability of technological equipment limits the quality of your STEM teaching? We had does not limit at all with 40%, 20% with limiting and does not limit much, and 10% with does not limit too much and a little bit limiting. In the question, is there any non-financial equipment you are missing that would be helpful for your STEM education? 8 professors said no, 1 professor said more access to recent literature, and 1 professor said professional application tools and technological tools. What teaching resources do you use when implementing STEM education? We have 9 professors that said official tools, professors said presentations with 8, and professors use software. 6 professors use audio materials, and 5 professors said application, and so on and so forth. How well do students achieve good results in combined STEM education? We have 40% with very much and solid progress, and 10% with very little and sufficiently progress. Is the teaching more difficult for students when using STEM? We have 30% with much simpler, and 20% demanding, and 10% I cannot judge, and more demanding. I will continue with the student survey.
Thank you, dear
Yes.
Diana, for your presentation. If anyone has some question, feel free to ask, please. If not, we can continue with next presentation. Our colleagues from Lublin University of Technology, Mikhail Arlat.
Alexandra,
Yes,
she's just presenting the student in different slides, I think. The next one is the student presentation, because, yeah, we
Student
put to one presentation, but
we put
she
two presentations for
divided
students.
into 2 parts. Yeah.
Yes.
can you please just repeat it again, because I cannot hear you well.
The presentation was only about teachers, not about students.
Yes. This one right now I will is about the students' survey results.
Okay.
We had 24 students from economics department and 39 from computer science department. 61 were undergraduate and 1 graduate. We had 50 students that finished the first year of studies, and the 9 students the second year, and 3 students that finished 5th and 6th semester. It ranged from 17 years old until 49 years old. And they're familiar with the STEM term in education. We had 32 that said no and 31 that said yes. How many subjects focused on a combination of math problem solving, technology, and science? Did you have any studies so far? We had 41 with some, 11 with most often, 6 said none, and 5 all of them. We had how many classes have you taken in each of these categories? In science, we had 33 students that didn't take science until the highest number of students of 15 that said at least 1 course. Engineering, we had 24 students that did not take any courses until 6 students that took the highest number of courses with 5. Mathematics, we had 4 students that said no courses at all, and we had 9 students with 4 courses and 11 students with 5 courses. Computer science, there were 20 students with no courses at all, and we had 3 students with 4 courses and 10 students with 5 courses. Other digital technologies, 19 students had 0 courses, and with 5 courses, there were 8 students. Does your school offer engineering courses or projects? 36 students said yes, 27 said no. Are businesses and industry also included in your STEM education? We have 34% with moderately involved until the lowest with 6.9% with not at all. Do you implement projects assigned by industry partners in your school tasks? We had 34.9% not yet, and we have 14.3% with no. In your education, do you often deal complex problems that are similar to problems in practice? We have 25% with rather not, and the lowest with mostly yes. Do you have classes in your computer classrooms? In the computer classrooms, 46 students said yes, and only 3 said, I do not know. Do you have classes in specialized laboratories? 60.3% said no, and I do not know with 9.5%. What percentage of courses, subjects do you use digital technologies? We have 4% that said at least 10%, and we had 4 students that said 90% and 100% use of digital technologies. In the future, I plan to continue STEM education. We have 20 students that said quite seriously, 17 students said rather seriously, 13 very serious, 6 very less serious, and 4 less serious. 3 students that said not at all. I see myself in STEM career. We had 16 that said I strongly plan to occasionally pursue STEM career. 15 said maybe I see myself in STEM career, where we have 7 in STEM career and 4 that do not see themselves in a STEM career. I would appreciate more changes to learn STEM. 30 students said that there are opportunities, and 3 students said that there are not opportunities, where 3 other said that they are not interested in learning about STEM. Rate or evaluate your skills obtained during your studies so far. We have I can solve problems and work with variables, where 3 students said very weakly, and we have 9 students that said extremely strong. I'm able to think logically. We have 25 students with the highest answer selected extremely strong. I can analyze complex problems. We had 17 students with very strong and 18 extremely strong. I can solve a problem, very weak with 1 student, and extremely very strong with 26 students. I can come up with a creative idea, very weak 1 student, and extremely strong 22 students. I do a critical analysis, very weak 2 students, and very strong 18. I am open to learn new technologies, very weak 1 student, and extremely strong 28 students. I can use digital devices such as computer, tablets, smartphones, very weak 1 student, and extremely strong 34 students. I understand basic software applications, very weak 1 student, and extremely strong 21 students. I can use and evaluate information from digital sources, very weak 1 student, and extremely strong 19 students. I can understand the basics of cybersecurity, very weak 4 students, and extremely very strong 15 students. And this would be all for the student survey results. I would like to thank you for your attention. Apologize if I took more time than it was
Thank you once again, Diana Latife, and sorry for misunderstanding. And our next presenter will be Mikhail Charlak from Lublin University of Technology. So hello once again. Hello to
Okay. Hello, hello. I got classes with me.
Hello.
Right. Okay. I would like to show you some more most important conclusion about this survey, because okay, I need to show you. Sorry, at the moment, because I need to share my screen. Okay, there it is. Okay, can you see my screen?
Not yet. Not yet.
It's not sure.
Yes. It is in progress.
Oh, okay. Because I don't know, but there are some problem with Zoom.
Now we can see.
Okay, there's some problem with Zoom today in Poland. I don't know why. All right, but I got some table behind me because I presented also for my student. All right, because I share my screen, but I can see that it is possible to see my screen or no?
Yes, it is.
Okay, all right. Okay, most important thing. I prepared this survey and I got answer for 64 students, but one huge problem to analyze this data. Because, okay, when I saw all of this data, and I will show you this answer, right, I think about this answer, but will be this way. But I show you this first screen. There are different kind of studies. At our faculty, we get only four different studies, and you can see there are 20. Because students write the name of studies in different way, and most important thing for me is to analyze the answer of student which the longest way at this studies, and especially at study of information and technology education, because they should have the most important answer, because it's two stages study, and they learn about technologies and about different information technology also, and also for example some pedagogy and other subjects. Another three different studies, it's for example math and data analysis, but and also safety engineering. But whole of this, okay, not whole, but we start only now. We start second stage of study for data analysis, and it starts 1 week ago. Second stage of the study, and to math there are also second stage, but there are only some students. But I would like to know the experience of the students which study a lot and get this contact with this different STEAM idea. And first, I need to filter this answer. I prepared an Excel, but I don't have any figure about only this one of this studies. It's information and technology education. But in general, what about the survey? Okay, you can find most of the students, it's nearly 60%. It's first stage of study. At this answer, of course. And at this picture, you can find that most of them study 1 or 2 semesters long. But at our survey, they check also 1 or 2 semester for students which study in second stage, not only first stage. And there are also answer from first stage students and second stage students. And you know, experience, if we compare this experience with some of these 2 groups, they are very different. And I check that most of this answer give people from second stage of studies. And there are very big experiences. This is the reason why I need to filter it for our publication, filter it using studies, not only in general, because there are some problems with interpretation of this figure, for example. Sex, most of them were men, and if we saw this figure about age, you can find that one of them is 45-year students, but there isn't anyone who used this survey, and it's also some bug at our. I think someone would like to be happy, for example. Okay, next one. If we ask about STEM, not idea, but about this word STEM, you can find most of them don't know this this idea, not this word, because if we connect it to subjects with use STEM idea, you can find that only very small amounts, only 3 people said that any subject isn't connected with STEM idea. But again, we should analyze especially this kind of study. I check it, and I saw that this answer gives some people from math, and they study at second year at first stage of the study. They got only 3 semesters, and the studies only theoretical in this moment for these people. And this is the reason why they said that there isn't anything. Of course, if we saw another pictures, another figure, you can find that, okay, math, because we have math at each courses, at each studies, and you can find that somebody said 4 people said that there isn't. All right, and something else. If our university offers some engineering projects, all of them said that there isn't. That's true. And again, question about business and business at STEM education. Okay, you can find also the same 4 people from math study. It's about students. It's about math study from second year of the study. Then they don't have any contact with business or at their studies. Yeah, it's true. But in general, when we analyze general, you can find something at this feature. But there isn't. If we analyze this answer from other year of the study, for example, from third year, there is, and there's a lot of contacts with business. Another thing, if this question about realizing projects from a business partner, most of them said they don't know. Why? Because our studies at second stage are connected with not business, but with projects, with realizing projects, and the people, the students are connected with these projects. And if we saw this general answer, we need also to compare it with not age of the student, but with number of semester which are they studies, but number I said about it, number not only at first or second degree study, but we need to compare in a different way. Okay, if there is an answer about problems with practice, connected with practice, of course, most of them said there is. That's true at our studies. If you have any classes at computer laboratory, all students said yes. All of this group of 64 people. Another thing, and you can find very fine things if there are any other laboratories than computer laboratories, and you can find 50-50. Yeah, why? Some of them have only for first stage of studies from math and data analysis. From these two studies, they got only theory from 3 semesters and don't have any other laboratories. But that's also, you can find, we need to compare it with this answer, compare with kind of studies and number of semester. Okay, how many lessons use HEIs technologies? You can find that most of this answers, but there are no answer, but there isn't. Okay, if I would continue STEM learning, yeah, you can find 2 people, but they are not interested in continuing this learning. Why? It's also from math. Awesome. And you can find that students are very interested in STEM, using STEM idea used at learning process, and we do it. And what about students? How we use? And you can find all of this figure were very similar, and most of them have strong case for using STEM learning from STEM education. Okay, and that's all. It's most important, and you can find that we should analyze these features, all of these features, connecting with group of students first with kind of studies and another thing, the number of semester. Because if we saw this feature in general, are not true this way. Okay, and it's about this survey for students and wait a moment. Wait a moment, and now about sorry for a moment. That works again. Some problem with Zoom. Yeah. Stop it. Okay. Another survey for teachers. Yeah, it works. Okay. Show it. All right. Yeah. There it is. Okay. So, if we ask about teachers, okay. I got an answer from 12 people, 12 teachers from different departments. From all of this teacher. Okay, I asked about the survey. Teachers, because you know, because you were at Lublin last year, you can find that we have different faculties from last year, and we have different teachers, yeah, and half of teachers at our faculty nowadays have some lesson with the student from our faculty, and half of them don't have anything with the student. And I sent the survey for the same people, because if I ask students from our faculty, I send the survey for teachers which have contact with the student to compare this answer from students and from teacher. And it was about 25 people, and you can find 12 answer. And of course, the same like our learning process connected with 4 different studies. The same way we have teachers for different studies. And again, we have mathematician and also mathematician for data analysis, like a practice. And also we have many teachers for security, for security engineering, safety engineering, and also we got people for education, for IT technologies, different technologies, and also for technologies like engineering. And at this answer, you can find that there are 2 answers from mathematician, and there are 2 mechanics. Most of them 5 answers from IT, and also electrotechnology, one of them, and also something connected with mechanical, tribology, and there's another people, and you can find 1 people from mechanical, tribology especially, and the same there are there are again 1 people for thermodynamics, like a specialist. And different knowledge, very different. And what are the answers if we use STEM idea at this education? And If we ask about possession of this people, there are half of them were adjuncted doctors, and a quarter is professor of our university, another one is professor, and there are 2 assistants. That's all people which could be at our faculties for different kind of lesson, different classes. Okay, if we ask about how long they work at our university, you can find that most of them work more than 20 years. They have big knowledge, and they work with students for more than 20 years. And there are nobody which work less than 1 year. And there are only 1 people which work from 1 to 3 years long. Okay, about sex. There are more women at our answer. And okay, integration of STEM at lesson, and you can find there are any answer for not using STEM at lesson. I'm proud of that answer. All of these people try to use the STEM idea at this lesson. Okay, if we think, if we saw there are more than 40% were rather yes, and there is also many also, and you can find that it's about 75%. They mostly use STEM idea at lesson. All right, then okay, and you can find that there's the same people, almost no, and okay, and this is the same assistant which work less than 3 years, and you can find this people don't use rather no use STEM idea. Okay, another thing, again the same people know about using STEM at teaching process, and you can find that most of them, it's more than 75% they use it at all. And if you use STEM for teaching, you can find 5 answers. All of these classes it's used for STEM idea. Okay, it's a very nice figure. You can find exactly about quarter, but all of this answer is from 3 to 6. It's answer for teaching process and integration of STEM at different kinds of lesson, and different kinds about knowledge, about maths and technology, engineering, different kind of classes, and you can find all of them use STEM. Of course, different ways of pedagogy methodology. Okay, we have different teachers also specialized at this different theories of pedagogy and didactic technologies. You can find all of them use it in different ways, okay, there are especially 6 different methods which are used usually. Okay, another thing about using STEAM at teaching. Okay, there are also similar for different specialization. Okay, first feature is some other. It's about using, but you can find that there are only 2 answers. But okay, it's the same assistant, which work only for 2 years and don't use STEAM for evaluating of programs of studies. All right, then about possibilities of find STEAM information for our lesson, for our teaching process. You can find that all of these people find this information and use it for learning process. They evaluate the teaching process, and you can find there were more of them, most of these people work more than 20 years, and it's also fine that they're interested in using different ideas of learning process, different ideas, and using it. They work more than 20 years, and they still would like to be better, provide this lesson in a better way. Okay, it's about different courses for better learning, and you can find that again there isn't an answer, not at all. All people would like to go to some courses about different way of learning, modern way of learning and teaching process. It's about business at our education. You can find that, yeah, we have very wide contact with business, and we also get some specialists for lesson. Some of them provide our lesson at classes with students. Sometimes we go to different manufacturer, for example, and to show something, some technologies for students. We use it. We use all of them. All of us use STEM and business contact at our STEM education. Okay, and of course, what about cooperation with business and education? And you can find that if we ask people which work more than 3 years, all of them said that they use. And also you can find one of this mathematician. It's a teacher which have only theoretical lesson, and I check it especially, and okay, at this lesson it's only about theory of math, and this is the reason why we find this answer for many questions. Okay, and okay, if, about using STEM at future at business and education, of course, also would like it. any other. It's also fine. Okay, you can find this picture is again the same value like first one. The same answer like at first question. It's about literature and different materials for STEM process education, if teacher can use it. And exactly the same way like at first question. Okay, and for mathematician, this assistant again. We ask about literature for STEM process for STEM education at this lesson, and you can find that there is a few work 2 years. Okay, about laboratories. Laboratories for STEM education, and you can find that all people said that there are, we can use it, and there are different applications for use it. About using STEM and different IT technologies, for example, for learning process. Again, most of them use it. And about equipment for STEAM process, and you can find that more people said that there are, but half of them said that isn't enough. Okay, and I think it's most important things. Okay, and about students. Oh yeah, it's also very interesting. And you can find that this is the same assistant which don't use STEM, and you can find that it's a good idea for using STEM for education process for students, and if it is easy for students to learn with STEM process. And okay, it isn't assistant. It isn't assistant. It's answer for professor. But it's much more easy. It's about thermodynamic. Okay, that's all for our question. And you can find that we need to analyze especially connection for student survey, connection with different studies and longer studies. Okay, thank you very much. If you have some question, I would like to answer.
Thank you, Professor Charlak. A few favors for you. First of all, since we have seen that you are with your students, please take your pictures and send it to us, please. Another one is please send us presentation with these results during this day, please. And the last one is about some financial documents. Vladimir sent it to you. He will resend it today. Please, you just sign it for transfer of money.
Okay.
Your work.
Thank you. Thank you.
Thank you very much. Next presentation will be given by Professor Andras Horvat from Obuda University. Hello, Andras. How are you, Andras?
Thank you very much. I'm fine.
Nice to see you. Nice to see you. Please take the floor.
Okay. Dear colleagues, I am Andras Horvat from Obuda University. And so this is not, oh, okay. Basics, data of 48 detections fired out the questionnaire based on the answers. The instructors have a lot of experience in the field of education. Nearly 80% have taught at the university for more than 10 years. 70% of those who filled out the questionnaire were men. And next position, Professor 5, Associate Professor 16, Associate Professor with a PhD, 16 Associate Professor without a PhD, 11 total, 48 teachers out of 85. Next part, the integration of STEM education at Obuda University contains yes and no answers in almost 2 equal parts. The majority of teachers use STEM in education. In education, the STEM method is more present in the courses. And the traditional direct instruction and inquiry-based science education approaches, professional development and experience in STEM. And next, professional development and experience in STEM. Half of the respondents would like to further their education, while there is a small proportion of those who abstain from further education. Institution support based on the answers, business and industrial partners prefer not to participate in STEM education. And would you support activities that facilitate between industry and universities? 85% of teachers support the connection between industry and the universities. Material support, how would you rate the current availability of literature and materials to support teaching STEM in your subjects? Our teachers are satisfied with the availability of the literature. And are the STEM laboratories at your faculty available for your teaching purpose? In their opinion, we hardly have STEM labs at our faculty. And do you have sufficient technological support when implementing STEM education to your subjects? There is no adequate technological support, 70%. Do you think the current availability of technological equipment limits the quality of your STEM teaching? 80% of teachers believe that the lack of technological tools limits the possibility of STEM education. The student achieve better results in community STEM subjects, and according to the majority of teachers, it is easier to teach students using the STEM method. It is the student part, mechatronics 90.3% and safety engineer 14% and one cyber engineer and 65.2% mechanical engineering, and there were students from all years in proposition. Most of them are BSc students. Total 207 students out of 2,000. 90.8 man and percent and 9.2% woman. STEM education introduction. 21% of students have heard about STEM education. The combination of math and problem solving, technology and science is present in most of the subjects. And business and industry are rather not involved in education. The students were divided on the question of whether they solve complex industrial problems during the training. According to the students, there are computer and specialized laboratories at the faculty. This is a technology and used throughout STEM education. Future vision. Sorry. Do you? In the future, I plan to continue in STEM education. Most of the students plan to continue their STEM education in the future. And I see myself in a STEM career in the future. Students prefer not to think about STEM careers. Increasing STEM skills, I would appreciate more changes to learn STEM. 10% of students are not interested in the STEM at all. According to the other operations, there are opportunities to learn STEM. Conclusions. The knowledge material of STEM education can be found on the internet, but the faculty lacks the necessary tools for its implementation. All teachers use STEM methods in their teaching. Students want to solve complex tasks close to industry and during their studies, and their lecturers would like to see more industrial realizations at Obuda University. And next, or teachers would like to improve their knowledge in STEM education. Thank you for your attention. And, thank you.
Dear Andros, next presenter will be Professor Emilia Madudova from University of Zilina.
Good morning. Thank you.
Thank you. Please take the floor.
Okay, thank you. So thank you very much. I'd like to present, and I'll finish with presentations about our surveys. So I'll start. I'll go through all the parts as my colleagues. So through first survey will be the teacher survey, and the second one will be the student survey. So sorry, goes. So our teachers teach in a field of economics, math, informatics, and technical subjects. The 55% of our teachers are with 20 and more years experience at our university. So all the question or most of the answers are from the most experienced teachers at our university. So the first part is a STEM education integration. STEM is, our teachers think STEM is integrated at our faculty. It's also very integrated in their individual teaching, and they mostly involve from the STEM education. Mostly they involve in their teaching digital technologies, computer and science programming, then engineering as it is, mathematics and science. And also the STEM curriculum at the lectures is multidisciplinary in the most of the answers. Their professional development and their experience in STEM is mostly they use project problem-based approach, teaching with experience, and less or the least was like gamification and games they use in their teaching process. They implement STEM in teaching occasionally, and they think their ability to follow trends and implement the trends is poor, and they are not very interested in STEM, but the explanation will be in a next slide. It is not the reason that they are not interested in, but the reason is some other reason. So I'll explain next time. At the next slide. And they are not very much interested in additional training or professional development, but I think it will be also connected with some other reason I'll explain later. So some institutional support. So university and business industry cooperation. As you can see, there is a strong business and industry cooperation included also in our educational system. There is a strong university industry cooperation in STEM education as itself. There is a strong cooperation in student training, but not so strong support from a financial side. So there is not very strong financial support. And you can see also in other question, their answers were if there is any financial support. So the questions were, the most of the questions was like rarely. Occasionally, they can see any material support and any networking between university and business industry cooperation. And this is the main reason I was talking about previously. They would like, they're not interested in some other or further education or any further involvement in STEM education, but the reason is they have no time for self-education, new courses, and so on, because there is no other time. I think all of us know this. There is no other time for some other activities, and also connected with STEM. So they mostly use presentations, office in general, and at our university we do not use robots. They evaluate the technological support and equipment as present. And how they evaluate any student's achievement. As you can see, they answer that they are not able or they cannot evaluate if the students are and how well are they achieve, and if it is difficult. The most of them couldn't answer because they don't know. But the others, some of the others answer that it's demanding, and when the STEM is integrated, that this is easier for our students. So other part is from our results of our student survey. So our research goal was monitor the students' possibilities to enhance digital skills to support STEM learning and teaching. Our field of studies of our students are e-commerce and management, distribution technologies and services, road and urban transport, economics, railway transport, and civil aviation. We had about, with teachers, we had about 22 respondents, and with students, we have about 102 respondents. So our students are not familiar with STEM education, but they are not familiar with term STEM, not with STEM education, but with the term STEM. So they think their proportion of education according to STEM is about, the most of them is science, and the similar proportion of mathematics, engineering, and computer science programming. They answer like 0 with other digital technologies, but I think they are so familiar with it that they do not realize, or they integrated it into computer science, that they answer like 0, but they use many other digital technologies. Okay, so their answers according to business and industry partners' involvement in STEM education. Interesting is that they implement projects assigned by industry partners, but they think partners are not included in their STEM education. And many of them think they do not deal complex problems that are similar to problem in practice, but as you can see, they think they implement projects and so on. So this is a good sign, not a good sign, but this is a sign for us to more complex introduce all these business industry cooperation to our students, to be very familiar with these terms. So their future vision, they would like to continue in STEM education, and they are very serious with this. And but on the other hand, they don't see themselves in a STEM career or slightly plan. But I think they're a little bit afraid of connections of maths and so on with engineering and science. But in the future, it's their job. So when they'll finish our university, they'll find anyway the jobs in like STEM professionals. So the last one, I have skipped some answers because there were no any extreme answers. So I'll skip to the last one. I have realized the cluster analysis because I wanted to see if there are some differences in their answers. And so I have used the hierarchical clustering, and I have divided them into, or I have chosen that I would like to have 3 clusters. So according this my input, the clusters, here are histograms of my results. So you can see this is the cluster number 1 of answers. This is the cluster number 2 of student answers. And this is the cluster number 3 of student answers. So you can see this is like their answers according to if they're familiar or not. So if they can solve some equations, you can see the first cluster is not, but the others are like they are familiar. If they are able to think logically, the first cluster, interesting is they think they're able to think logically, strong, but they cannot work with variables. So, but it doesn't matter. But they can come up with creative ideas, and this cluster, on the other hand, they cannot do the critical analysis. And you can also see any differences in the other clusters. So I think we have to see more complex analyze these results. We have to evaluate it according some hypothesis testing, because from these answers we can now I cannot evaluate some correlations or some associations between these answers, only in this part. So thank you very much for your attention.
Thank you, dear Emilia, for this very, very detailed presentation. So now, according to agenda, we have another topic, HMI lab and its use for STEM education. Also representative of the University of Zilina, Professor Dr. Radovan Madlenak, if I'm not wrong. So
okay,
please take the floor.
Okay, so greetings from University of Zilina, from the Laboratory of Human-Machine Interaction. And my presentation, or maybe my speech here, will be divided to the 3 parts. First of all, I will introduce you my laboratory here, the equipment that is used for research, not for only for research of teachers and researchers, but also for the students, for the diploma theses and some topics, some subjects. And then I will show you. Then I will show you some information, maybe some use case, how to use it, maybe how use one of the software that I have here. And then I will show you one equipment here that is for the remote collection data. Because I have a lot of equipment here, and when I want to do some research on showcases, so I have to invite the people here. But I have also the equipment that is used for remote collection of data, and I can't use. I use just the web camera for the data that will be processed later in my laboratory. So at the beginning, I will show you here. I will move with my camera that this setup is set up for eye tracking research. Here's a eye tracker that monitors where you are looking at the screen. This is the static eye tracker. I have also this mobile type. It's a glasses, eye tracking glasses that can be wear on the tested subject, and everything can be recorded where the tested subject is looking for. I will share with you the screen. I don't know. Oh, well, share screen. Well, sure. So my screen is here divided to the various parts, but here this is the view from the eye tracking glasses, where you can see where I'm just looking in the real conditions. Everything is recorded, and I can use it for my research. This red circle shows where I'm just looking. That's just the demonstration, the view of this view from the eye tracking glasses. Well, I have another. That's the eye trackers. I have another device. It's a device that detects EEG. It's a detection of the brain activities, and I have one equipment here. That's the EEG had them set, and I will show you the screen again, where you can see. Yes, you can see. That's the brain activity. That's my brain. That's my brain, and you can see the activities in the brain. You know, the brain is divided to the two parts. One is left part is dedicated to some kind of some rational processes, and another part is dedicated right part is dedicated to emotional processes. And now you can see in real time the brain activities, and I can monitor the brain activities in my brain. And now, well, that's the view from I think that this one will be. I can move the brain from various angles. I can focus on various type of waves that can be visible on the screen. Well, that's the another type. I will take off this tool, and I have also this software here. This software is software dedicated to measure the activities, the biosignals from the tested subject. You can see here that I have here the eye tracking signals here. I have here the camera. Camera is located here, yes. And that camera is recorded my face, because I can analyze here the face expression of the tested subject. And I have also here, just for a while, this shimmer. Shimmer is a tool that measure the GSR. It's a galvanic skin resistance of the tested subject. And now I will show you the preview of the sensor that can be visible from this software. The software is integrator of various type of sensors. And here at the slide, you can see just the few signals from the I'm sorry, few signals from the sensors. For example, here it's here is a valence. It's according my face analysis when I'm my mimics on my face is positive. There is a valence that comes to plus values. When it's negative or something is problems, you can see now that I'm not so in good mood now. Well, you see -4 minus values of this valence. It's a very interesting. It's a very good very good values for the measurement how the tested subject is feeling when he's tested. Another, it's engagement. I have a more of this activities, or maybe emotion. Can be anger, content, disgust, fear, joy, sadness, surprise, and other signals that can be in real time analyzed. And other confusion and other. I will remove all of them. And the valence will be here just. And I have a data here from the eye tracker also. That's the signals. First of all, it's a pupil and distance. It's a pupil size of my eyes. It's again the reaction of the human when watching. Sometimes your pupils are higher than in other times. When you are surprised, wow, the pupils are bigger than diameters of the pupils are bigger than in a normal situation. And it's another one. It's a distance from the eye tracker. It's the last one. It's normally when you're watching on the screen something on the screen, sometimes you focus on that. So the distance between you and the screen, it's not so far. It's for example now it's 60 centimeters, and when you are relaxed, you go down, and the distance is much higher. Well, that's the introduction of this software. But once again, I can use this software only for the measurement here in this laboratory. Or I have various another types of eye trackers, and that can be mounted on the notebook, and I can take it and go to the clients and do the testing. But it is not so comfortable. Now I will show you my presentation dedicated to, it's the third part of my presentation here. It's a presentation dedicated to how can we use the remote data collection, the iMotion software, for remote data collection. That's some introduction to this. We are using iMotion software and the iMotion Cloud or remote data collection that can be used for collection data from the study distributed in the browser. I will show you how I can create a study, and then I will share it with the clients and respondents, and they will do the experiment at home and upload the data to me, and I will analyze it later. What are the requirements for this RDC study? First of all, you have to have the iMotion software. It is not so cheap, but I think that it's a good investment for this type of education of the students. Then you have to buy not just software, but that software consists from various modules. And you have to buy the remote data collection module. You have to have internet access, and then you have to log into one page where you can manage the studies, but you will see. Here's some recommendation for this type of studies. First is minimize demands on the respondents. We will use just web camera for that. And during the study, the respondents must be focused in some position. You will see later. So the recommendation here, it's a study duration must be under 10 minutes. Maximum stimulus resolution is 1090, 920 and 1080 pixels and 30 frames per second for videos. And when you do this, you can disable screen or camera recording when it's not needed. Just focus on the experiment. You will see it later. Here is a principle of this remote data collection. First of all, you have to design your experiment in the software. Then you upload this experiment to management center and myemotion.com and distribute it from this place by email. I will distribute just the link for this experiment to the tester, and then you will monitor the data collection and download all the data to the software and analyze it. How to do it very quickly? First of all, in the software, I will create a new study. Here is a option. What can I do with this software? I can do the screen-based study, glasses, screen recording, also mobile devices. Using the Smart Eye Pro, that's the special eye tracker. You can use this study or this software for virtual reality. And you can also create a test plan for it's the management of the study. Then we just choose this online data connection. Yes, it's a remote data connection. Then we will choose the sensor. For eye tracking, we will use just the web camera, and we also analyze the respondent facial expression during the testing. So we use the respondent camera for facet or AFDEX analysis. There are two types. It's a very technical, but we can use it. It must be highlighted. And then I click next. Then I will select the sensor. There is information about this sensor. Eye tracking with web camera is based on the web camera that is installed in your notebook or maybe on your monitor or some external web camera, and that web camera must be calibrated before and after the testing. And facial analysis can be used for facial analysis. There are no additional requirement hardware is needed because we use the data from the web camera. Again, the iMotion offers the voice analysis also. When you are talking, when you are doing something, I can analyze the voice also. Then name the study and I will create. That's beginning. Now I will open the study builder. In a study builder, I just created that I will do the remote data collection. Now I will create the experiment, and you can choose from block, calibration, media, survey, website, or Qualtrics data. That's the view on the emotion study builder. Calibration is obligatory for each study. Pre-study calibration and post-study calibration. It takes approximately 40 seconds, each of them, and I will show you how it looks. You will sit in front of the camera and looks on the dots. Yes, dots on the screens. Your head must be fixed. It's very good. You will see later how it will be, but this is the calibration process. Then select the stimulus, and you have this option to choose. Block. It's when you have a very big study where you can mix when you have a various type of stimuli, pictures, videos, and other. You can create the blocks for the study. Calibration, it's a calibration that you saw. Media, it can be image, video, or audio files. Survey, it's a survey where you as a respondent will answer for the questions. There can be also the website text testing, and Qualtrics server website address can be included also in this experiment. Well, when you create it, you just edit stimuli button to open this study builder, and here you have one option to preview flow. When you want to see how it looks, you just click on the preview study button, and you will see how your experiment will be visible for the testers. Then, when you are working on your lab, on your computer, now you have to upload the created experiment to the My Emotion Center. That's the web page. From that web page, you will manage the experiment. Just click and you will see upload to Emotion Cloud. Then confirm, yes, confirm to study to iMotion Cloud. This option is here, and you can close your software on your computer. Now you log into My Emotion Center. You can see the study overview there. For example, you can see here the information about the data collection. For example, here is the information about one of the experiment that it's the stimuli details. That during the experiment you will record the participant microphone. Before the testing, there must be check of the microphone, or maybe audio outputs, head position if we are using web camera for the eye tracking, and some consent screen that you agree with the details with this experiment, and end screen, thank you page, or something like that. Then you can see here also view stimuli details. Here you can see, for example, stimuli details of the experiment that you create. You can see, yes, there is a pre-calibration, survey, website, black screen, and post-study calibration. That's the type, position is fixed, duration, how long it takes this type. For example, calibration takes approximately 40 seconds, and the second calibration also 40, but survey 30 seconds. Everything you can set up in the study builder. Then you can see here the when you set up the experiment on the My Emotion, you just click on the star remote data collection. That's I think here, yes, start data collection, and you are starting to obtain the data. Very important for you for sharing this experiment to your potential tester is this link. You can copy this link and send to respondents, to the tester, because according to that link, the experiment will be open them to the in the browser. Okay, now I will switch from the from the manager or creator or experiment side to participant side. What are the recommendations for the tester or participants? First of all, must be the respondents have to have the camera. Another option here, or maybe it's obligatory, to consent to participation. You will see on the experiment, and then enable camera recording, microphone recording. Technical requirements here that the respondent must have the desktop or laptop computer. The phone or tablets are not supported now, but are not supported for that. Participant must have Chrome, Firefox, or Edge browser. Internet Explorer and Safari are not supported. It's important to have the latest version of the Internet browser. And the participation must be done on a operating system Windows, Apple, or Chrome. And participant must provide video file formats, or camera must provide the video file formats MP4 or Windows Media Video. WebM, the new format, are not supported, but I think that all camera has this opportunity. Another requirements for the tester, it's a participation must be done while sitting at desk with adequate lighting. I'm sitting in front of the desktop. Very important is when you will have a fixed position chair to minimum movement, because you will during the test experiment, the web camera will focus on your head. When you will move, there is a problem. Ideally, participation and resulting camera recordings would be in front of the plain background. I have a camera in front of me. Direct lights, other faces, and other people are not should not appear in the background of the camera recording. You have to be alone in the room, and the camera must be located in the top center of the screen. It's an ideal position. Notebooks has implemented the camera on this position. Okay, so now that's the walkthrough of the. Now will be walkthrough of the participant or tester. First of all, when you click on the link that will be shared with you, this welcome will be appear on your browser. That's the consent with this consent to participating to the study. You have to check it and accept and continue. Then must be study setup page. We will share the recording of the screen, and you have to set up that you have to set up that you will share the screen. You have to enable screen sharing. There are various options. One option is sharing the just window, but I recommend you to sharing the all screen. Then it's a participant enable of the microphone from the on the participant side. First of all, you have to enable the microphone. Yes, so you will see here the menu and the forms where you can select the web camera and select microphone. Then you will check the sound if it works properly or not. Yes, and if it passed, you can confirm the settings. It's okay. Then you we will share the screen recording. You have to share. You have to define the screen size. Screen type. It's a laptop or desktop, and screen size. It's a diagonal size in inch. For example, if you have a 32-inch, yes, you choose this screen. And now is everything okay? And now you will set up the full screen browser, not just window it, but it must be the full screen window. And that's the recommendation for the placement and lighting. Here you can see the information how you have to sit and how the lighting must. Okay. Another one. Next, it's a live feedback. Here is a very important part where you can see the placement of your head during the experiment. You have to have your head in green oval, yeah, like this.
Most ki van itt, várjál, jön egy másik, amit elmegyek ismerni, mert nagyon
Hungarian.
Nem a kép a lényeg, hanem hogy szép vagyok, nézd meg.
Okay, so now here is some study instruction page. You can click it, and now it's a study instruction page that is shown before the start of study. And open a new lab. You can see, and after that, the experiment will pass. There will be eye tracking calibration, data collection. And at the end, when everything will be finished, there will be automatically the data that was recorded on your computer will automatically upload to the My Emotion page. And here is a video, but we haven't a time for that, I think. So I will skip this video. The presentation will be distributed on the web page, I think. And I prepared for you something, some test. This test is here at this link, and I can copy link, and you can. I will share it on the Zoom chat. I hope that there is a Zoom chat. Yes, and you can. I hope no, just E. Oh well. Oh well. I don't know. Edit link, copy link. Well, you can try this remote data collection in your computer later, and that's end of my how to prepare this the presentation, how to prepare it. And now the last part of my presentation, I will show you the result of I created one presentation, or maybe one testing of this, and I will show you how can I analyze it. There is just one measurement, but you will see it. That's here. After that, I download all the data from my emotion and upload it to the software, and I can analyze the data. Here I can see me, and the testing is dedicated to the crossroad testing. Yes, when your vehicle will cross this junction or maybe the crossroad. Yes, and I will show you analysis, and you can see here my camera, how they record me, and I can show you here you can see my face, and here you can see the position of my side, where I look. Yes, that's interesting. I'm just using the web camera for that, not eye tracker. Eye tracker is very eye tracker cost approximately my cost 20,000 euro, but I just use this web camera for that, and the results are I think that the same. Yes, for example, I can see here, I will close it. Here's the signals, fixation, saccades, and other. That's the technical signals, but I can show you here, for example, heat map. Heat map, you can see here where I focus during my study. It's just experiment testing from one man, me, but you can see here where is where my gaze was focusing during this study. Another experiment, another analysis that I created, it's analysis of the oh well, not here, analysis of signal processing. No, okay, sorry, it's not that one. Oh wow, not save, cancel. It's here. Open signal processing. Is there option? Yes, affecta. I will create a raw data aggregation. Well, what's the problem? Oh well, okay. No. Oh well, it's here. I will cancel it. And open analyze and see the signals. Yes, here I can see the emotion analysis. I can see here the balance. Yes, it was neutral, but sometimes it was positive. But it depends on the study. But I can see here, for example, anger. Is there any anger? Yes, maybe here. My face was not so good. Maybe my eyes, the movement of my eyes was not so good. Maybe fear. I have a fear here. Oh, there is some types of fear. Surprise. Yes, a beginning. Yeah, something happened. Everything is according my mimics on my facial expression. Here you can see what kind of facial expression is taken into account. That's quite big analysis. Well, that's all, and that's end of my presentation here. I hope that it was interesting. If you have any question, please send me or maybe contact me, or I will monitor the studies. Here is the study that is dedicated to experiment that I created for you, and I will again copy the where is it? Copy the link to the chat, and if you will have a time, just try to do this analysis. You will see from the respondent point of view how it looks. Okay, so thank you very much. I'm sorry that I was I had I spent a lot of time for my presentation, but I hope that it was interesting for you.
Thank you once again, Professor Madlenak, for your very interesting presentation. Yes, and we have useful time with this presentation. So thank you once again. According to agenda, we have two presentations from Obuda University, and I suggest to not make any break because we are a little bit in time delay. So I would like to invite now Professor Dr. Victor Gonda from Obuda University to present the presentation Collaborative Workshop Module in Moodle. So
Yes, thank you. Can you hear me?
Hello,
Can you hear me?
hello, how are you?
Hello there. Hello, everyone.
Okay, nice to
Okay,
see you
I'm
and
trying to
Lord.
start it up now. Let me share the screen. Let's see. Okay. So, can you confirm that you can see the screen?
Yes,
Oh, thank you. Thank you. So my talk is about a collaborative workshop module in Moodle, and let me get straight into it. The workshop is a powerful peer assessment activity. Students add submissions, which are then, let me just, distributed amongst their peers for assessment based on a grading scale specified by the teacher. So the idea here that we do basically a collaboration over the, let's say, the internet by using the so-called Moodle environment. And the idea is that the teacher gives an assignment to the students. Each student has an individual assignment to complete. When the student completes it, he makes a submission. And then in the next phase, this submission will be reviewed by fellow students. So, and this is done for each of the students. So each of the students will be reviewed by one or two other students. They give opinions, they can give marks or points or whatever. And at the end, the teacher also reviews all the work and gives the final mark. Yeah, in principle, the workshop, how it is implemented in Moodle, it has several phases. The flow in the workshop module may have like 5 phases. And the typical workshop activity can cover days or weeks. Well, the example I will show you, it will cover basically 2 months of activity. And the teacher drives all the phases. The teacher switches from activity from one phase to the other. A typical workshop follows a straight path. And in this implementation, there are basically 5 phases: a setup, a submission, assessment, grading evaluation, and the closing phase. As a remark, an advanced recursive path is also possible if it's needed. The progress of the activity is visualized in a so-called workshop planner tool. It displays all the workshop phases and highlights the current one. It also lists the tasks the user has in the current view, and it shows whether the task is finished or not yet finished, or even if it's failed. All right, let me just get straight to an example. This is a view, the teacher's view, while I'm setting up the whole workshop. Maybe in this first screen, the important thing is that within Moodle, what is the subject that the student is following? Actually, this is an example for the Forming Technologies course. the important deadlines are all covered here. So deadlines for the submissions, basically it covers about 4 weeks. And then there are 2 weeks for the assessment, and then the closing of the workshop. As you see, it's an actual work that has been done basically a year ago. The opening was for the submission at March the 8th in 2023, and it was closing down with the evaluations in May the 4th. So basically 2 months of work was done. Another view that I'm showing here is basically a phase where some evaluations already coming in, and that's what, again, the teacher sees. These blue boxes are, in reality, they are not there. I'm just covering some sensitive data with the student names and some gradings here. But in principle, you have the list of the students, you have the list of the assigned topics. There are some incoming points, the reviewers given points following, and then some final assessment points to be collected in here. I'm showing in this example maybe just let me emphasize just a few things. The definition of the assignment first in here for this example. So as I mentioned, this is related to the forming course, and for the assignment, the aim was an overview for the student to have an overview of technologies of parts created by mass production and chip-free forming processes in manufacturing technology, especially regarding to the upsetting reduction. So that's one technology, blanking punching, second technology, and deep drawing technologies, that's the third technology. All right.
I'm sorry, Victor, we see the same presentation, same slide.
Yes. So you see the slide, all right.
The first slide.
You only see the first slide.
I see, not the first, but yeah. Okay, it's better now. Okay.
All right. Now, okay. So you okay. You missed these two. That's what you're saying?
Yes. We missed the only one. I'm sorry.
Okay. I'm sorry about it.
Okay, and now we saw this one.
All right. Okay. So we are at the workshop assignment. Anyway, I'm continuing from here on, if you allow. Okay. Thank you for the notice. Let's see here where we were. So we use so 3 technologies are chosen to be worked with. And we use then the framework of the model workshop for the task. And during this workshop, the student work will have 2 phases, basically. First, development of the topic, and the second one is the evaluation. So creating the assessment to use the phrases of the Moodle, and then the assessment in the second point. So first, each student receives an individual topic, an assignment, as a result of which they have to present the production technology of a part by plastic forming on presentation slides and with a short text summary. In the second phase, 2 other students' works must be evaluated. Those who, for example, was assigned to the technology of compaction reduction or upsetting reduction. In the evaluation, he or she will receive the other 2 technologies to review. Okay, so that's the idea of the assessment. Basically, the concept is that the student works on one topic and reviews the 2 other topics. So in principle, in the study phase, he has to study all 3 technologies, but only executing the, for example, to creating PowerPoint slides and some introduction text related to one, and then do the evaluation of the second two. Now, all right, let me just try to pick, there are coming some formal requirements related to the submission. Let me roll on. And then also the teacher defines some assessment considerations. Maybe I'm sharing this now. So there's related to the format, the length and the structure of the submitted PPT and docs are in accordance with the announcement, for example. And related to the content, does the component match the designated technology, whether the theoretical summary is substantive, whether the presented technology is correct and understandable. And there's also option to have any further suggestions, remarks, or comments. All right. So when the assignment is done, then in the second phase, there's the peer reviewing arrangement, and basically it goes in a way that here's a student. His submitted work is reviewed by two other students. Here are the two other students' names. And this student reviews two other students' work. Yeah, here in this column comes those names. And this arrangement is done for each of the students. This can be done automatically. There's a random assignment and there's a manual assignment. I find actually what I did here was using the manual assignment, but that's I think that's a small detail. All right, let me just pick one. Maybe I'll just show one set of slides that the student created for such an assignment. The corresponding written text is not here, only just these pictures. So for example, this one was related to reduction and upsetting. So a typical part is a connecting element, for example, to create. There's a summary of the theory behind of the upsetting and the reduction technologies, how to combine these technologies, what machines to use, what are the steps of the manufacturing, and there's a summary at the end. All right, when we're reaching the final stages, all the points are collected, then in this kind of an experimental run, I choose to evaluate myself, all the students individually and then I define the final grades, of course, considering also the grades that the peer reviewer fellow students advised. And this is how this workshop was closed. Okay, we reached the end, so thank you for your attention. If you have any questions, please, I'm happy to answer.
Thank you, Professor Gonda, for your presentation. We will have now next presenter, Professor Agota Drageli-Kish from Obuda University, and presentation will be using the Moodle quiz for assessment. Please, Agota. You cannot see me at the moment, but I can see you, and you are so beautiful, I have to say.
Thank you very much.
Okay.
Thank you for your kind showing. I would like to speak about using the Moodle quiz for assessment. And it is some kind of research work was made by ourselves, and I would like to show you what were short. What is the topic? So we've got a subject name, so-called measurement technique, and all of the mechanical engineering studies, all of the mechanical engineering students, it is a compulsory subject for them in the 4th semester, and 1 lecture and 1 lab exercise in a week. It is this is how it's going. It has 3 credits in 3 ECTS credits for that, and they should write 2 tests within a semester. And I do this test via Moodle system, and I use a lot of Moodle questionnaires, and I have all the answers since 2018. And I would like to show what are the differences between the several question types and what I found about this. And I would like to show you what kind of different questions do we have. Could you apply during the engineering subjects during its assessment? So the conditions were during to write this test that it could be done anywhere, not at the university. So they can use what they want, like in a real life. And okay, it could be cheating, but I would like to don't think about this. The time interval was about 15 minutes each. And the order of the questions was random, and they are random. And the order of the answers with the multiple choice is random as well. So it's difficult to do it, find out what are the next topic and so on. It's a bit difficult to search for the answers. So I would like to show you 7 quiz types which I was used. The first, in the first part of this presentation, I would like to give you some examples. The first one is drag and drop onto image. It's quite interesting. You know, I'm teaching measurement devices, so they should know what are the elements or the parts of this equipment. So, and I have to say that this is one of the easiest question type. But it could be good whether they know or not. The second type is essay. This type of question this allows students to write at length on a particular subject and must be manually graded. Its advantages that students cannot guess. Disadvantages for these essay types that since the last year, I can show you with numbers or whatever, it's so easy to ask the ChatGPT or other artificial intelligence tool for this question, and they answer in that way, in that manner. So, okay, I gave them 0 points, but I think that this essay could be not good in the future. The third type of question is true and false. A student is given not only 2 choices for an answer in this kind of questions, true or false. It's quite easy, but okay, you can guess it. 50% of guessing. If you have right, yes, we have to deal with this kind of probability. The fourth question is my preferred one. So I have to say that multiple choice. Moodle provides teachers with a lot of flexibility when creating this common question type. You can create single answer or multiple answer questions, include picture, sound, and other media in the question. I prefer to use multiple answer questions in case when only one is enough and one is the only version. So I used to use this type most of the time. You will see with the numbers. So the fourth type of question is multiple choice, which were used by this engineering course. The fifth one was matching question type. So you can see during these matching questions have a content area and a list of names or statements which must be correctly matched against another list of names and statements. So there is two pictures. This is some kind of measurement error on the picture, you can see, and there are several types of errors, and you can choose which one is which. You have only 2 pictures, but you have several types, I don't know, 8 types of errors, and you can choose the good one. Or in the right side of the slide, you can see several types of dimensional measurements signs, and you have to know what does it mean each. Lexically, all right to say. The 6th one is simple calculated question type. It's good. Yes, we are. They will mechanical engineers, so our students have to calculate somehow. So this is once during the simple calculated questions offer a way to create individual numerical questions whose response is a result of a numerical formula which contains variable numerical values by the use of wildcards, so-called this X and Y, that are substituted with random values when the quiz is taken. So it is how looks like in Hungarian form this sentence, and they have to round the measurement result. And I will give for numerical value one random value and another random value, and after that the measurement results looks in this way, and you have if it is the same number, it will be say it is good or not good, and it will assess if you will do the assessment or evaluate this question automatically. And the 7th one is so-called numerical question times. Question type is different from the simple numerical one. It's from the student perspective, a numerical question looks just like a short answer question. The difference is that numerical answers are allowed to have an accepted error. This allows a fixed range of answers to be evaluated as one answer. You know, when you are just seeing one test in a written form, you will say, okay, it's almost good, I give grade for that, it's almost not good, that's why, and so which is the good response and which is not, and this is how we can handle it via model types. So these are the 7, and the 8 sub is the short answer question types. In a short answer question, the student types in a word or phrase in response to a question. So the answers may or may not be case sensitive. If you are if you are asking for a phenomenon or some kind of definition, and they have to do, okay, this is it, or other. So if it is some kind of phrase, it's a good idea to use this short answer question type. Okay, so these are the 8 used question types, and you can see here some diagrams within each categories, and you can see that with these green ones, that multiple choice used by myself most of the years, and you can see it's around 300. I have around 300 questions, and of course, the students, one student should have to answer maximum 50 or 55 questions only, and the others is rest. So you can randomly choose it. Several questions could randomly chosen for the students, and that was the reason. But almost the half of the questions are multiple choice, and you can see this orange one is numerical one. Yes, I improved this ratio of the numerical one during the years, and the essay is the same. There are several, but in the first year I do not have so many time for preparing good questions. That's why I put a lot of essays, but in 2024, I will decrease the amount of essay much more time. So you can see how it looks like. And the results of the solved test, so you can easily know how many of the answers are good within the students or not. And you can see here the different types of questions, and the average grade, it's 100%, this is the normal one. So if everybody knows the answer for the certain question or certain types of questions, it gives to 100%. So you can easily compare with each other the different types of questions. And you can see the green one, that is the most easy, the so-called easiest questions. And the green one is the matching type. And the second one is the blue one. Or sometimes the blue one comes in this way. So this blue one, you can see this blue one is the drag and drop into image, and the other blue one is simply calculated. So the wrong question from the point of the students is simply calculated, or the numerical ones. So you can see that the average grade is much more less than the others. So if you would like to, it's up to your choice how to make this proportion from the different types of questions, and it will show you a common grade or something like that. But they have significant difference between the different types. I make some groups, so-called. One is for the so-called reading devices. So I would like to know whether our students are able to read the measurement devices itself. And two types of questions you can see, and you can see that they can read it around 60%, 70%. So we are not able to teach them as much as they could be. It's interesting for us to know it, but you can measure it in this way. The theory, you can see if you are focusing on the questions related to theory, which means that you are able to read it in the book, you can check it into the book. You can see if you are write essays, that will be the best choice. True and false, I'm so sorry. True and false, that this is the easiest way. Then the matching type, then the multiple choice, and of course this essay, because if they are using only Ctrl+C, Ctrl+V from a book, or they use the GPT, I give them 0 for sure. So that's why you can see in 2023, it's much more less than the other, because I realized that they are copying or they are using the AI. So that's why I gave them immediately 0 for that. And it looks in these questions. This is the all question types. I put all the questions and all the average grades you can see here, which were used during the 6 years. And you can see the median value for drag and drop is almost 93%. For the true false is 84%. For the matching type is 72%. That is the median, and for the simply calculated is 32.2. So this is the most difficult for the student to calculate this this exercise, or how to say this, to answer for this question. It is the most difficult for them. Yeah. I would like to have some conclusions that multiple choice questions are properly adjudicated here, ease of grading and efficiency in assessing basic knowledge. However, they must not effectively measure higher order thinking skills or provide insight into deeper understanding. True and false questions are straightforward, but can be limited in assessing complex understanding of critical thinking abilities. Short answer questions allow more flexibility, enable students to demonstrate understanding in their own words. It could be interesting. I speak a lot about essay questions, but matching questions are useful for assessing knowledge of relationship between concepts and terms, they can be effective for evaluating understanding, but may be limited in assessing deeper comprehension. So the effectiveness of online question types depends on factors such as the learning objectives, the level of learners, and the subject matter. A well-designed assessment should include a variety of question types to accurately measure different levels of understandings and skills. Thank you for your attention.
Dear Agota, thank you very much for your presentation. As I mentioned earlier, we will not make a break now. We will continue in order to realize all presentations on time. So next presentation will be from our colleague from Lublin University of Technology. Next two presentations, actually.
Yeah, I would like to ask to add my colleague because Agnieszka couldn't connect. Oh yeah, now I can see her. All right.
Yes, 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 okay. So you will present now using the question bank for creating tests in the Moodle, yeah?
All right, we got another problem with Zoom. I think it's a problem in Poland with Zoom. Please wait a moment because run not work some key at computer only for Zoom. It's not my computer. It's Agnieszka one.
Yes,
But
yes, yes,
I
yes.
don't know. There are some problems with Zoom today in Poland.
Okay, then next presenter will be.
I try to do something with her computer.
Okay, shall we continue with presentation from Dr. Agnieszka Ganzel? Or both of you have the same problem?
It works now.
Oh, hello. May I ask you, please, just to be within the time for the presentation?
Okay.
Okay. Thank you. Please take the floor.
Okay. Wait a moment. Because I will change
microphones. Okay. And now it should works. Should works. And let's go. Okay. We get again another group of students at this presentation. Also sitting with us. Oh yeah, it works. I can see it. Okay, questions. Everybody can see Agnieszka presentation or no? Can you hear me?
Yes, 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 we can hear you.
And you can see this presentation? No?
Yes, we see.
Okay, let's start.
Będziesz tłumaczył.
Okay, don't worry.
Dzień dobry, chciałabym opowiedzieć o edukacyjnym escape roomie, zastosowaniu escape room w edukacji.
Okay, Agnieszka say hello, but she's very shy and don't want to say in English.
Dzień dobry, Agnieszka.
Dzień dobry.
Okay, I will translate in English. I think it's proper way.
Jeśli oglądaliście Państwo film z Indiana Jonesem, to były tam elementy, gdzie Indiana Jones musiał włamać się do katakumb, znaleźć w środku kamień i wydostać się z tego cało.
Okay, do you remember some movie? Some movie is Indiana Jones sequel. Agnieszka asked about this film because this hero of this mission was to break into the catacombs and find some alchemical stone inside to get out alive. And Okay, this character combined this experience, archaeological knowledge and mental ability to meet the challenges before him.
Musiał połączyć swój bystry umysł, musiał skorzystać z pomocy przyjaciół, współpracować z nimi i żeby osiągnąć swój cel, pokonać swoje różne trudności, lęki. I właśnie w obszarze edukacji również możemy stworzyć takie katakumby, z których trzeba uciec.
His goal was to find treasures or valuable items and get out to traps life, fighting the dangers and threats. Along the way, he had to overcome his fears, work in team, trust the skills of these treatments, and finally achieve his goal. In the field of education, we can generate similar experience to enhance or improve students' learning process through physical escape room or virtual one on digital platform. Escape room are considered alternative, innovative teaching methods that are based on the assumption of gamification. You can find some literature about gamification, and I think it's nowadays it's going to be very popular. Especially at young people, which people are young. I think about people which are between maybe 15 to 20, because I got some information, but I got some experience with this not escape room, but about using gamification for this group of people, these young people. And you should know that in Poland, it's going to be very popular, especially at secondary schools, at technician schools, especially there are last year or some more than 1 year, there in Poland, people produce a lot of different gaming application for this gamification for people, for students especially. They get knowledge at lesson, and then before they go to laboratories, they use gaming methods, and they trying to be better than other people. And okay, you know that in technologies there are some problems with not only knowledge but using. And of course, if we think about gamification, we use virtual reality and other application for do it gamification, but of course they are not real. They are not real. And for example, if they take hammer to this hand, they can fit it and they can use the strength. But if they use virtual reality, it's impossible. But of course, it's gamification is used for, especially for take the schools how to do it. These cases, especially one what we have to do this operation, for example. And The same way we use escape room, Agnieszka especially, use this room for students at our university, at our faculty, and she used escape room. She would like to show you something at this escape room. Yeah, and now we'll go to escape room. There are, of course, many different things about escape rooms. This presentation, you can see it after our conference, and also you can try to go to this escape room. Let's go to this escape room. She showed you how to do it and what you can find, what treasure you can find at this escape room.
Przy tworzeniu escape roomów należy wymyślić jakąś fabułę. Nasz escape room będzie odbywał się w budynku uczelni czy szkoły.
The aim of this escape room is primarily to motivate students to acquire knowledge, engage this process, and create an environment in which all participants actively work and have fun. They learn, build a team, and are able to continue while solving problems, which is important to developing computational thinking and important factor that influences students' interest in the escape room is preparing tasks at the appropriate level of audience. The task cannot be too easy because students will reach the goal very quickly, or also not too difficult because when they see not solution and they will give up. Okay, let's go to this escape room, maybe.
Tak. Mój escape room jest zrobiony na platformie Genially.
Okay, Agnieszka use some platform. It's Genially. Especially for escape rooms.
I nasz escape room nazywa się Lost Key, ponieważ będziemy szukać zaginionego klucza.
Okay, this treasure is the lost key, and you should find this lost key at this building.
No i tutaj musisz tłumaczyć.
It's Agnieszka.
Yes.
Avatar used. And this lesson is going to the end, and we couldn't go to home because there are no key, and it's hidden, and we don't know where it is, and you should try to find it. And Agnieszka showed that there are many different doors, and choose one of them. And at this room, there are some math equation to find solution.
Klikając na różne przedmioty można spotkać rzeczy, które wyskakują, ale nie są to rzeczy, na które chcemy odpowiedzieć. Jest to ukryte pytanie.
Okay, there is this question, math question here, but you can click at different things at this room, like this picture before and another, but you are trying to find this key. And now you can find this question, how old is the Lublin University of Technology? And now you should find a solution. The best solution is 70.
Yes.
Okay. Yeah, it's fine, but you should remember this number which are shown, and there are 7. Okay, first question we have, and next door, there are different things at this room again, but we are trying to find this question. Okay. This application asked to find again this question, but not works in this way. Yeah, it works. What color in the Faculty of Mathematics and Technical Informatics mark on the campus map of the Lublin University of Technology? And it's yellow. Okay, Agnieszka checked bad answer and there isn't anything. And now, good answer, this number is 8. And we will go next to the next room, because we need to collect all answer, all number. And chemistry. Okay, it's explosive. Of course, we are going very quickly and we don't show everything because you can click at different things at this room because if students or people would like to find a solution, don't know where it is and can find, of course, many information at these rooms, many information connected to this, like at this building, this different laboratories, for example. And of course, we need to find this question and find solution to this question. And now there is 6. It's proper. And again, we got number, it's 2, and we will go next. And last one, room. And of course, we are trying to find any question. And another question, please put a bad answer to show how it works. Okay, it's bad answer. You can find that it's bad. And we are trying to find some good. Yeah, that's great. It's number 0. And we are going next. And congratulations. You find all question and going good. And that's all. And now we should find all those balloons. But we need to destroy it, but using this number in proper way. Number from each of this room. And now let's go. Okay, it was first number 7.
Jaka była następna, kto pamięta? 8.
Okay, proper. Okay, and that's all. And you get this treasure, which was its key. And in this way, you can find solution and also finish this this test. In this way, of course, this test is for smiling, and we can prepare some not so funny, but we use also another test which are combined with different knowledge and also, for example, math equation and any other. First idea is to use this method to interest student. To interest student to they not finding solution for any question, but for trying to finish this test. But you can find that this test is prepared in so different way than any other. And young people would like to find something interesting. I think it's important to find solution to interest young people. Okay, it isn't so fast. It isn't so fast, but you can find that another thing. At this platform, you couldn't change this window like Professor Goda said before. They can use especially artificial intelligence like ChatGPT. Then this way, you giving these young people something which they're trying to find solution, but don't know in this way where it is, and usually they don't remember that they have also internet because there are small time for give this answer for this question, and they interest all of this building and different things to getting new knowledge, and at the finish they are trying to connect it with practice, for example, like solving some question. Okay, I think that's all. Thank you very much.
Thank you.
I think it was interesting for you.
Thank you very much.
Okay, thank you, Agnieszka. So, Michael, will you continue with another presentation or no?
Yeah, we can continue, but we should change computer.
Okay.
My computer and change microphones. Okay. Okay. All right, I'm here, yeah. And now this presentation. Yeah, let's go to share and go. Sorry, again, with some problem with Zoom today. But close it. Okay, maybe it will work. Yeah, maybe it will start. All right, again. Oh yeah. So okay. All right. Yeah, it works. Okay. So I got okay. What is the idea of my presentation? So this some of the subject of prepared for Professor Agota, and I find that there are about using tests at Moodle, but I would like to show you something very useful. I think some of you know about it, but it's also a very good solution if we have some problem with students which would like to find some information in the internet, and what else we can do, how to prepare some tests at Moodle platform, and how to do it quickly, and you can see. All right, that works. Okay, fine. Okay. If you are preparing some quiz at Moodle platform, of course, we get some settings. You know about courses and quizzes. I think this information is for you known, and something else. How to do it quickly, and how we can use many different questions for a group of students. You know, sometimes we preparing tests at laboratories, and these computers are very close, and the student would like to find a question to the neighbor computer, and
how to do it? Okay, you know, but we can show this question in a different way. But there's another thing, question bank, and of course there are settings. You know it. Very good date, and also another thing. There are time. How long they can put this information, because if we do it preparing this test, for example, for student, and our lesson, we take 1.5 hours, and we can put there this information, how long we can do it. For example, 10 minutes or 13 or 30, and this time limit, if they saw it, because student case can show this information, and if first they would like to pass this test, they show that they have only, for example, 1 minute. They will know before the start that there are very high limitation. They couldn't use any other sources of knowledge at this test. It will be very fast, and so of course depends on our question. But another thing. Okay, where we can question, and at this presentation, I will use question bank, of course, but another thing, because I use this Moodle platform for some years, and you can find another thing. It's the last version of Moodle, and at this version, sometimes different configuration are put at very, sometimes stupid places. For example, there are questions, there are question banks, but there are quiz, and you should solve it. There are this addition for question. Yeah, last time at 1 month ago, I would like to find this button for 2 hours, because I would like to find it at question and question bank, and I couldn't find it there because it is at quiz. Okay, it's some trouble sometimes, but at this platform, sometimes it's different configuration for users, of course, and before version it was easiest, because you can find all of this configuration at one place. All buttons for some quick and easy things to do were at the same place, and sometimes at this newest one, it's very hard to find. Okay, let's go to questions. Okay, there are questions, and something else with tests. Something which could be very useful. Of course, we can put this note for each of this question, like points, like here. You have you can also use different points. Here we have four different questions, but each of them has the range of 1. Yeah, but we can put different points at each of this question. You know, some of them is more difficult, but there's another thing, very useful, maximum value, and it's not addition of these points, but all of this question, all of this answer for this question will be added, and this punctuation will be added. But for example, I use some tests which have, for example, 20 questions. But I would like to the node known for students, not in parts, but I would like this node like in Polish, like 5, or you can use, for example, A. Yeah, and maximum value in Polish education system is 5. If I put there 5, all of these points will be summarized, but if we put more points at some of this question, it will be also better weight, and will be added, and Moodle platform will calculate it automatically. For example, there is 20 points, but I would like to put node 5. I'll show you some answer in a moment. You can find that if we use this maximum value, it's very easy for us to not check it using by hand, but put this node in automatic way. Okay, another thing, there are some answer, and you can find there are nodes, and for example, there are 20 questions, and you can find that there are 1 point, but it is divided by 4, and we get this node which student know. Because if we preparing some courses for students which contains, for example, some tests for each chapter or each lesson, and student will collect notes, sometimes it's difficult, for example, to give some good number like 100. And sometimes it will be added, for example, 81. And if students will finish lesson, our subject, we don't know if this 81 is positive or no, or if it is very good note, or maybe no. But if we use this maximum value every time, they will show this note, like the no from all education system. And I think it's very, very useful, not only for teachers, but also for students to know their knowledge and to know exactly what is the node. Okay, remember about this. Okay, that's another thing. There's question bank. There's question bank, and you can find. I prepare the 30 questions. 30 questions and this question bank, and I said that we can give this question in different way. Okay, we can prepare this test in this way, but we will use 20 questions from 30 in different way for different students also. And this way, we can prepare, for example, 100 questions and for 10 peoples. And okay, I tested that students group, and they find that some of this question will repeat more frequently. I don't know why, but it's happened sometimes at this platform. For example, when we put this information that they should be used only 10 questions, it's happened that 8 of them will show for 2 students at 10 people group, and we don't have this receipt nowadays. Okay, but you can find that this question bank it's very fine because we can prepare it not only before test, but we can use, for example, some questions from last year or another and add it to this question bank. And then we can use different configuration of this question. We can edit it, of course, but we can also put which of them should be used. For example, if we would like to use only 20 from these 30 questions, we can also put information which of them should be used, but then we should remember that it is a quiz, this add question, because then we will add it, but they will be not add to this test. And again, there will be no one at quiz. If we go to questions, it's questions, but then we have to go to quiz configuration and then add all of these questions from this bank. Not all of them, but all which we put at this question bank to be added to our test. A different way of using, but it's very fast. If you know all of the steps, how to prepare it, and for example, we have to prepare some tests for another group of students, it will take about 5 minutes. If we get this question bank, it's very, very useful. Okay, thank you very much. And if you have some question, I will give you some responses.
Okay, thank you, Michael. So the next two presentations are from University of Mitrovica. The first one is a smart classroom, multifunctional smart room for interactive education and connectivity by Vladimir Maksimovic. Michael, sorry, can you please stop sharing your screen?
Yeah.
Thank you.
Hello, everyone. Can you see my presentation? Okay. My presentation is about smart classroom, multifunctional smart room for interactive education and connectivity. What is multifunctional smart room? The multimedia smart room is an innovative space concept that integrates advanced technology to enable interactive learning, lectures, and conference activities. As you can see in this image, we are currently in this conference room and running this webinar. This room is equipped with various multimedia devices such as smart cameras, interactive projectors, ceiling and gooseneck microphones, and other audio-visual equipment that enables this system to be functional. On this image, you can see our conference room and our two classrooms. In this schematic view, you can see 3 classrooms. 2 are regular type and 1 in the middle one are in conference type. So on this schematic, you can see there between these rooms are shrinkable walls. So if we need a larger space, we can shrink these walls and get one big room, or if we need 3 separate rooms, we can shrink back these walls and get 3 rooms with 3 independent audiovisual systems. For what purpose can a smart room be used? For regular teaching, because we can record the lectures, online classes, some external professors in the lectures, workshop and trainings, conference rooms, team meetings, and so on. But how was that achieved? As I mentioned before, with some cameras, microphones, projectors, Wi-Fi presenter, and so on. I will demonstrate and say about this equipment, what they are capable of. In this conference room is equipped with 2 cameras. These cameras have some features like gesture control, some audio tracking. It comes with 2 lenses. One of them is with 36 total zoom. They are PTZ controlled camera, and the second AI wide angle lens. That AI technology such as speaker tracking, smart room, gesture control enables to capture every attendance up close with some premium video quality. As you can see, our image, this just a moment. This conference, this webinar is run by this camera. Okay. And 2 of these cameras are in this conference room, so I can control by pan, tilt, on, or zoom. The other one are equipped with AVR-DL30. So this is for basically for teacher tracking, when teachers walk between tables or through the classroom, the camera will automatically track. There are also preset zones for for table, for smooth type writing on table, to not be shaking camera and so on. Camera will automatically detect preset zones and keep camera still. I will later show that. Of course, there are some microphones on this conference room are gooseneck microphones, but they are not just regular microphones. They also play a key role in enhancing the functionality of our cameras. So they have ability to precisely locate the source of the sound, and cameras automatically track and zoom towards the speaker, ensuring the focus is always on the person actively communicating. So these microphones help camera to do better audio tracking. On the other regular classrooms, there are ceiling microphones. So these microphones are designed to pick up voices from all parts of the room, allowing all participants to hear each other crystal clear, no matter where they are. So also these microphones are with also and speakers, and have some features like some noise suppression, double tag detection, and so on. Every room is equipped with projectors. This one is with interactive projector with a pen, so we can during the presentation draw some lines, shapes, or type something, write something, and so on. Also, we have multimedia Wi-Fi presenter, so every participants can just simply plug in HDMI port in HDMI port this dongle, and image from their laptop will automatically present and display on our system, so we can manipulate with those image sources. Every room is equipped with additional monitoring. In this conference room are 2 additional TVs and some speakers in every angle. So we can choose which image source want to be displayed on each monitor. So on one, it's possible to display the camera image on the one TV, the online participants' image source on the second, presentation on the projector, and so on. And we can control sound level in all rooms with these speakers. There are a lot other equipment, but I mentioned some basic that enables this system to be functional. But all equipment is stored in the wall racks. And as you can see before in the previous slides, most of equipment is wireless. So for equipment that is not wireless, the cables are in the wall and there are interface in the wall for each device. I presented some features for cameras. So as you can see, control is not required because the system is fully automated. But if you need control, the system can be manually controlled using Stream Deck or tablet device. As you can see, I'm here with some tablet and I can do zoom in, zoom out, or some pan tilt control, or I can control this meeting. The user interface is user friendly, so there is no technical knowledge. There is no need for additional technical knowledge to understand this system. I would like to play some short video, our promo video, and describe part of them to see how it works. As I mentioned, the system is wireless. There are no cables at the table, so microphones on the table. There are additional TVs to present some other image or to video control. There are automatically speaker tracking. The camera detects sound and automatically track the speaker. Gooseneck microphones with enable, disable. It's interactive projector dongle for present image for other laptops. Of course, here is other classrooms equipped with teacher tracking camera. As you can see, while teachers walk through the room, the camera automatically track them and activates presets when he is at the table. Of course, there are projectors and ceiling microphones to detect sound for teachers and for students. And equipment is indirect, and this is manually controlled room. So that's all. Thank you for your attention. Does anyone have a question? Okay. Now my colleague, Professor Branimir, will present his presentation. Thank you.
Hello, my name is Branimir Jakšić, and I will present multimedia television system at the Faculty of Technical Sciences, University of Kosovska Mitrovica. The multimedia HD TV studio at the Faculty of Technical Sciences was designed to be multifunctional, to be used for the educational needs of students on the master's study program in multimedia communication technologies. In this picture, we can see concept of this television studio. The studio consists the following rooms: reception room, studio, director room, machine room, editing room, graphics, and desk. The TV studio is designed to that there are three scenes. The first scene is designed to be neutral. The second scene is background with director room, and the third sense is with green background. It is for virtual TV studio. In this picture, we can see director room. Depending on the concept of the television center, director room is mostly made up of video mixer, audio mixer, video switch, matrix, monitor wall for visual image control from various sources, electronic graphics, audio connection equipment with studio staff, sound, director room, and all other technical studio departments. The layout of the device in the director room is such that it allows each team member to see the image and signals, to hear the commands, the program tone, and the instructions to be addressed. In the machine room, in the rack, there are devices that emit great heat and bring noise. So it is equipped with cooling devices and soundproofed. In the rack, there is a video switch 20 matrix, a patch box, a server, various converters, audio, video distributions, and computers. In the room that is designed for editing and graphics, there are computers with the necessary softwares, such as Adobe Premiere, Adobe After Effects, Photoshop, Illustrator. In this picture, we can see schematic of video systems, and there are presented connection devices, cable type of cables, and ports for connection between devices in the video system. And in this picture is presented connection between audio devices. In the implemented studio, the software implementation of the virtual set was achieved using the vMix program. The computer that owns vMix has the appropriate hardware and deck link for Q card, so the signal is received from the camera. In this picture, we can see how virtual TV studio works, and the multimedia TV studio at Faculty of Technical Sciences has interactive connection with other TV systems. Two basic ways of delivering video signals over an IP network are downloading content and streaming content. With the streaming content, it is not necessary to download the entire content, but it is sent in real time and then immediately deleted. The protocols most commonly used for streaming are HTTP live streaming, real-time transport protocol, real-time streaming protocol, real-time messaging protocol, real-time messaging protocol encrypted. There is example of connection our TV studio with TV studio from faculty in Belgrade, and general conclusion of this presentation and our multimedia television systems is the that in addition to allowing for the production and the realization of television programs, this system also enables educational students in the field of television technology and multimedia production and post-production, such as recording of TV content, graphic processing, editing, visual effects, live broadcasting, and more. With this system, students can get knowledge with the principles of implementation of TV programs, as well as with the work of multimedia systems from the engineering aspect. Thank you.
Thank you. According to agenda, now partners from Universum International College, titled Using AI for STEM Courses by Oran Razzi. Stop share. Are partners from Pristina here?
Yes, we are here. Is it okay if we continue with Professor Elir Berisha, since I don't think Professor Oran is here
Yes.
at the moment, but I will let him know.
Yes, it's okay.
Okay, thank you so much.
Thank you.
Okay, thank you, and hello to everybody. First of all, let me just share my screen here. So thank you again, and hello everyone. Today I will be presenting this presentation about virtual reality and augmented reality in STEM education. The topics that this presentation will be covering are the technological fundamentals of VR and AR and their differences, examples of these two technologies in teaching various STEM subjects, the benefits and limitations of immersive technology in education, and the future directions for these two technology. First of all, what are these two technological methods such as AR? AR is a short term for augmented reality, that augments our surrounding by adding digital elements to a live view using camera on a smartphone. On the other hand, VR is a short term for virtual reality that is completely an immersive experience that replaces a real life environment with a simulated one. So practically these two are, if we can say that, the difference for the opposite of each other. In AR, the digital world comes to us, but on the other hand, to the VR or virtual world, we go to imaginary or digital simulated world. How does AR or augmented reality works actually? The key components are a camera, a headset, a processor, a sensor, and a controller. Let's say that to use AR, we just need a smartphone, a tablet, or something like that. In this picture on the slide, we can see a concrete example of how AR actually works. Everyone in this room, if may say, or everyone in this world have used AR, because every one of us has used Google Earth to find directions, and this is practically a concrete example of how AR works. If we pay attention to this phone, we can see an arrow on it that tells us the direction. For example, if we are in a foreign country, we are looking for a hotel or a mobile store or something like that. On the other hand, the VR, virtual reality, is the use of computer technology to create a three-dimensional artificial environment. We have three types of VR. They are these three types: non-immersive, semi-immersive, and full immersive. The differences between these three types are all about how much the users are aware of their reality. A concrete example is these two people here that are using VR with headset. In STEM education, they are very important technology to use because with virtual reality, students can learn concretely about lots of things, such as, let's say, for example, of the properties of bridge buildings, or to learn more closely about the human heart, because everything in VR can be looked or studied in three-dimensional space. The key differences between AR and VR, as I said before, are that in augmented reality, we go to the digital world actually came to us using a smartphone, or let's say we are just watching a movie on Netflix at home, but we want that our room and everything that surrounds us to be more decorated. We can do it using AR. But in the other hand, virtual reality is completely the opposite. It's completely a science fiction twist. It's like getting a human body and teleporting it to a whole new world, as we can see it in this picture. Other differences are how we can use it. AR requires a device like smartphones, tablets, or Google Glasses. On the other hand, VR uses only specialized headset and powerful computers to create an immersive experience. So the key difference is that AR allows the users to interact with both virtual and real world at the same time, but VR does not allow that. It surrounds us completely from our reality. Here you can find a link for everyone who needs to learn more about AR and VR to check as a reference. Also, there are some other differences using VR and AR. So as I said, the key difference is to how much the experience is real and how much is it's not real, and how to use it using smartphone or a specialized headset. Now we can learn more about how VR and AR actually are applied in teaching various STEM subjects such as biology, mathematics, chemistry, computer science, physics, and engineering. In biology, with VR, students are allowed and can learn more about human body in detail, because every organ can be studied in three-dimensional and see precisely where is the position of that organ inside human body. In mathematics, it has lots of applications. For example, we can learn more about geometric shapes in three-dimensional surfaces and more concepts about calculus, such as limits, derivatives, integrals, and their properties. Chemistry, students are allowed to explore the three-dimensional structure, also computer science to explore algorithms, or physics to learn more about different fields such as magnetic, electric fields, etc. Here, for example, in this picture, I've showed that how we can use AR and VR teaching mathematics. Let's say, because I'm a lecturer of mathematics, let's say we are explaining to students and teaching them how to find the area or the volume for different geometric bodies or geometric surfaces in geometry, such as pyramid, cube, spherical spaces. And here, using AR and VR, we can take a close look to see what is precisely a height, what is a width, what is a radius, and what else actually tells us. Or we have so many different applications, especially in mathematics. Here, to do this presentation, I took lots of images from an application called CalcFlow. We'll be seeing it later. For example, on the left side is this application tells us precisely what is a double integral, because to do it without this technology or without mathematical applications, it would be a very problem to learn and teach to the students, because to draw this area in three-dimensional. It's very problem because it requires lots of lines and it's not very clearly. Now using these applications, we can move 360 degrees in the right and the left, go in the bottom or all sides and learn precisely. For your information, this area in blue, it's what we call in mathematics double integral. On the right side is a strip that we call the Mobius strip. It's very common in mathematics, especially in topology. The key here is if we start from the bottom and we move across the strip, we'll be getting on top. To make it precise, this is how we use virtual reality on this strip and directly application using CalcFlow. So we started from the upper and we go to the bottom of the strip. It's very applied in mathematics. Of course, in terms of equation, it's not that simple. Of course, for your information, I'm not that guy that is in this presentation. I took it from internet on one of the link I put as a reference. Augmented reality technology and applications gives a fresh perspective on experimental activities performed in the lab. Of course, students can learn more about structures and feature for, let's say, a chemical element or algorithms or three-dimensional spaces by using videos, pictures, animations. But these tools are limited, as I said before, because using AR or VR, we can move to any direction, to any direction of that, let's say, chemical element structure or building or whatever we are learning. This one I titled VR is changing the way we teach math, and I absolutely agree, because mathematics is often considered a challenging subject to learn and teach. Of course, I can affirm that for my students. They are all the time just asking questions about that and that. I think why happens that because the traditional mathematics, learning from a textbook or what we write on a chalkboard, sometimes it's not it does not fill that gap between abstract concepts and concrete mathematics, and this is precisely what VR and AR are doing. They are providing a three-dimensional stage where mathematical concepts become more concrete, such as let's say three-dimensional spaces, surfaces, limits, derivatives, and everything can be seen in three-dimensional space. Here on this slide, we can see an different example using a calculus application. For example, how to find the gradient options or how to find the contour plot or other things that are known as vectorial analysis or vectorial calculus in mathematics. That to do it with calculation it takes lots of time. The next slide, it tells us the advantages and disadvantages of VR. To make it short because of the time, the advantages are immersive learning, repeatable scenarios, and data collection and assessment, and lots of the advantages we talked until now. But everything that has an advantages obviously has disadvantages. In this case, they are motion sickness, cost and accessibility, and isolation and social disconnect. VR, lately it's been very famous process, but it costs a lot, and that's a very problem. Of course, the isolation, because some students or humans in general are sick of using VR, because as I said, VR is a completely an imaginary world and isolate us from our reality, and to some students that it's not good. Here in this slide, we can see another application of 3D virtual reality. For example, how to study the grades, the lines of second grade, such as circle or ellipse, parabolic or hyperbolic curves. We do using this spherical conic. We can understand it better using AR and VR. Okay, so we are at the end, the future directions for VR and AR. Virtual reality and augmented reality have the potential to change or transform the educational landscape, and not just that, but to transform our life. I think the best things that are from VR and AR are personalized learning, because everyone can have an individual. Students needs to learn more about, let's say, integrals, can learn it about with VR, simulation-based learning, and learning about in experimental way. So at the end, we have just a conclusion. We said that AR creates a mix of real and virtual world. On the other hand, VR creates an entirely virtual world and isolates us from our reality. AR, it's used mostly using applications for smartphones. On the other hand, VR uses helmets and specialized glasses. AR aims to enhance the real experience. VR creates a completely new reality, and both of them are used, as I said, in education, in STEM, in medicine, gaming, interior design, and other applications. So this was it. I hope I don't took so much time. If you have any question, of course, I'm all yours.
Thank you very much. Can now Oran Ratzi present this presentation?
Yes. Are you guys able to hear me?
Yes.
Okay.
Thank you.
And I'm assuming you're able to see the presentation as well, right?
Yes.
Yes, we can see.
Thank you very much. My name is Oran Ratzi, and I'm from the Institute for Business Intelligence Studies. And I was charged with the task of preparing a presentation on how to integrate artificial intelligence in higher education. Just a quick overview of the what's going to be covered in my presentation. Say overview of AI's role in transforming education, the growing integration of AI tools in learning environments, and this is not limited only to higher education, but to education system as a whole. AI potential to personalize and enhance educational experience. What are some of the key objectives of AI adaptation in universities and colleges, and the importance of understanding AI's impact on higher education. Before I continue, I wanted to show you this slide, which is almost 40 years old. And I'm assuming most of you guys are familiar with who Bloom is, Benjamin Bloom, because you are involved in higher education. Most of you have used Bloom's taxonomy when you're developing your courses. But one of the things or the theories that Bloom presented is the Bloom's 2 sigma problem, which analyzed 2 PhD dissertations and analyzed the data from that. And that showed that conventional learning which was developed in conventional classroom, meaning 30 students per class, 1 professor teaching regularly or in a conventional way. This is the bell-shaped curve of their achievement. But if you took a group of 3 students and you provided one-to-one tutoring to them, then this is what the bell curve looks like. So it's a 2 standard deviation higher. Or if I can explain it a little bit better, it's if a student here got an average 7, a student here would get an average of 9, 2 grades higher. And this is as a result of tutoring and how that contributed to student learning. Something about it's all about learning, not all about teaching and how you learn from your experiences. The reason why I mentioned this has to do with the fact that until now, it was very difficult to find tutors for 3 students for thousands of students that were involved in higher education. But with the integration of AI, now some of the personalized tutoring is possible, and maybe we can see a hike in students' achievement based on the integration of or using the AI in the educational system. Let me go to, okay. And before I go a little bit further, I wanted to share some statistics which are jaw-dropping for almost everyone involved in higher education. It says that 43% of US college students admit to using AI tools like ChatGPT for studying. 90% of students who study with ChatGPT find it better than using a tutor, which answers one of the questions to Bloom's theory. Half of the teachers in this case, which is us, use AI themselves for lessons and for planning. AI great prediction technology, which is something that we are going to talk a little bit later, was able to identify and save over 34,000 failing students. And being in the Balkans and knowing what a problem the dropout rate is, such predictive tools can help us understand problematic students and try to react before they drop out or they fail in certain classes, which would later result in them dropping out as it is. The AI education market is predicted to reach $20 billion by 2025, and 2025 is only 3 years from now. But what is very striking is that more than 11% of college and school papers worldwide contained AI-generated content since AI was started being used, and most of that was in the past 18 months. So what are the current trends in AI within the higher education? There has been an increase in using AI for personalized learning paths. There has been an adoption of AI for analyzing student performances, development of virtual assistants for student support. And students are now creating their own GPTs, which are helping them to learn better. Implementation of AI in administrative tasks for efficiency. And this doesn't have to do with administrative tasks only for students, but also for faculties and administrative staffs within the institutions, and the expansion of online learning platforms powered by AI. Who are some of the key players in AI for higher education? We have Coursera and Audacity. I'm assuming most of you guys know the Audacity and Coursera. Then we have Google and Microsoft, who are kind of leading the AI tools, Microsoft with ChatGPT and Google with Gemini. And then we have also the IBM Watson, which is similar to ChatGPT and Gemini as well, but it's a more personalized learning experience. Then we have startups which are developing plugins for chats, for bots, different bots. And then we have partnerships between AI companies and also universities, having somewhat of a relationship with the UNI, and also because of their relationship with Arizona State University. There has been a huge development in, for example, ASU now partnering with OpenAI to develop courses and also to develop tools that will help students stay in class, perform better using AI. What are some of the benefits for the students? There's a personalized learning experience based on individual performances. I know it's very difficult for the institutions or even for professors in university to develop a teaching methodology or class activities that fit all of the individual needs. And that has never been the role of the university, of course. But now with AI, you can kind of predict how students are learning and what is better for them. So in a sense, you can personalize some of the information so students can perform better in class. You have a 24/7 access to an AI tutor. and the tutors can be developed for individual classes. I know Professor Ilir was talking earlier regarding VR and AR in mathematics. You can develop a tutor for math, you can develop a tutor for biology and for other classes as well. What are some of the benefits for professors? AI tools for grading and assessing student work efficiently, insight into students' performance to tailor their teaching methods, so you don't have to wait for an exam or an evaluation, or also for student feedback at the end of the semester to know about how they wanted to learn and what didn't go well. So you can, using certain extensions and certain GPTs, you can learn that a lot faster. And then just to showcase some of the platforms that are out there that can help professors and students in order to perform better. I'm assuming Turnitin. Most of you know Quizlet. I'm assuming you know that as well. Socrative, which is a real-time student assessment tool. Grammarly, which is being used by professors and students to improve their writing skills. Duolingo, which is an application that can help you learn a language, but now is being integrated into philology department, so it will go hand in hand with professors teaching students a certain level of language. And of course Coursera, especially Coursera with the courses that are specifically developed for AI and also for prompt engineering or for analyzing certain problems in order for the students to perform better. And then you have Google Scholar button. I just did a training with some higher education professors in Kosovo, letting them know how they can use AI to summarize and give you faster feedback on articles that you could use for your own article in order to write it. So it can summarize, it can bring you top 10 articles which you can use in your article as a literature review as well. And then you have Pear Deck, which I use when I teach as well, which is an interactive platform for professors who want to engage students during the presentation. So if the students are doing a presentation, you can use Pear Deck in order for students to ask questions, to get involved, to rate their colleagues, and so on. Interactive PDFs for engaging teaching materials. This is Orbit Note, which will read the PDFs without having you to read that, to read them for you. And then, of course, you have digital tools for students as well that they can use. Usually they go hand in hand. For example, Quizlet AI can be used by professors and from students as well, which is an interactive learning tool where whatever the professors are providing, the students can use this tool in order to learn better and try to fit it with their style of learning. Koggle, which is a platform for mapping and brainstorming. I don't know if any of the participants teach project management. They can use this platform, which is great for mapping and brainstorming when the students are trying to develop the concept of a project proposal. Then we have ChatGPT plugins, which I'm going to show in a short bit on how you can use it and how you can move through them. There are challenges, of course. If a student is turning nowadays a paper, everybody's wondering how much was written by the actual student, how much is written by an AI. But the role of the educational system now should be to develop mechanism not to protect from student cheating, but to develop the learning experience so the student, even when using AI, is still learning and achieving the learning outcomes that you plan for the certain course. So this should be the rule rather than just kind of throwing away the idea that AI could be used in higher education. And also, in the end, and is based on what I said earlier, is that the education is changing, and we have to change our approach. We have to think on developing assessments that are project-based rather than just traditional old-fashioned assessment methodology that we have used thus far, because students are beating us with the AI, and there's no way of knowing what the students are learning if we are not going to change the assessment methodology, and also using AI to the benefit of the student rather than trying to protect only ourselves. This is it, but before I go, I just wanted to let you guys know, for example, are you able still to see my screen?
Yes.
Yes.
Okay. So this is, I have the 4.0 version of ChatGPT. But to make a confession, the whole presentation that I did in front of you, I made it with ChatGPT. And now ChatGPT has a function here, which is a VBA, and I'm assuming all of you involved in computer science would know, but it will give you the code, which then you can put it into development part of the PPT, and then you can create the whole PowerPoint presentation from scratch. And then I also wanted for the presentation, the AI to read some articles for me, so then I can include it in the presentation. And I did that as well. It summarized the article and it gave me the feedback that I wanted. But then still I had to go back and look and see whether there is a structure. This is going to happen more often than not. And I think it's our role as educators to see how we can adapt to these changes. Another thing that I wanted to explore with you is explore the GPTs. And here, there are GPTs that will help you write. There are GPTs that will make you productive. If you're in the graphic design using Canva, you can generate the subtitles for the YouTube videos that then you can translate it into your own language. Let's say you're getting something in English and you want to translate it into Albanian or Serbian or any other language.
I'm sorry, but we see just thank you for your attention page now.
Oh, sorry. Let's see.
No, still there is a PowerPoint. Ah, now, yes.
Are you able to see it now?
Now, yes.
Okay, so this was the prompt that I was using earlier. I apologize. Let me go. I hope it will load. Never mind. Okay, so these are the GPTs that us as lecturers can use. And you can use GPTs for different parts. So for writing, for productivity, let's say you're a researcher. I know Scholar AI. It's a great plugin that you can use. And with the actual prompt, you can just say, I'm writing something on artificial intelligence and higher education. Can you give me the top 5 cited articles? And will give you the abstract for the top 5 cited, will give you the links, and you don't have to do a lot of research on that. I know it sounds like cheating, but this is the platform that we have now in front of us. And if we want to be productive and spend more time in understanding how the students are learning rather than doing administrative tasks, we can use AI to our advantage. And this is, I think, maybe my last thing that I want to say regarding this presentation. Thank you very much.
Thank you very much. Thank you, everyone. Just okay. Thank you, everyone. I think that's all by the agenda. Now we have time for some discussion. I hope you had a great time today at this webinar. So until the next time, we will see. Bye.
Bye, everyone. Have a great day.
Thank you very much. Bye bye.